All right, good evening. It's 6 o'clock, so we'll go ahead and get started. Just want to let everybody know the session is being recorded. So for those who couldn't make it, and those of you who couldn't make it, it is being recorded so that you can view it again later if you miss anything or want to go back and review anything. All right. So it's been a couple weeks since we did the last one. What I'm going to start off with today is we're going to go over some user interface code, some Java GUI, putting a window up on the screen. That's really what the current week material is you are in right now. And then after we do a little bit of the UI stuff, then we'll kind of go back to week 3 stuff, which is really what your assignment is actually about inheritance. Mainly about inheritance, but we'll cover that after the UI portion. And then, we'll talk a little bit about the assignment, and then we'll have any questions that you may have. All right, so let's get started with UI. So UI stands for user interface. You can also say GUI, which is GUI, that's graphical user interface. All right, that's a way to show windows on your screen in Java code. Windows just like anything you would think with a normal window. For instance, my IDE here is a window with a whole bunch of little widgets and controls on it, right? We're going to go through a simple example. We're going to make a very, very, very simple calculator out of Java UI code. All right, so first thing, let's start with putting a window on the screen. In Java, a window is known as a J-frame. That's just what a window is. We call it a J-frame. So let's make a J-frame, a new J-frame. Let's see if I can make this bigger. 1 second. Let's see if we can make the text bigger in this. Where's the preferences? Properties. Yeah, I think it's in settings. Editor. Yeah, let's make the font size bigger. 13, let's make it 18. See how big that is. All right, yeah, that's better. You can see the code better now. Okay, so we'll make a J-frame. And in here, as the first parameter, we put what the title of it is. Let's call it my title. Okay, so now we have made a new window. We haven't shown the window on the screen yet, but we have made a new window. So let's show the window on the screen. Well, let's put some comments in here. Create new window. And then let's show window. We do that with frame.set visible and make that true. So that's all it takes in Java to make a new window and show it on our screen. Now, this is going to be a very small window because we haven't put anything on the window. We haven't set its size. We haven't even set its position, but it'll make a new window, just really small. Let's compile it and run it. And as you see up here in the top left corner, very tiny, and I just drug it and made it bigger, we have a window. It's called My Title. That's the title that I put in there. That's our window. All right. As we saw, it started out really tiny, like that big. The reason is we don't have anything in the window yet, or we didn't set its size. So let's change that up a little bit. Let's give the window a specific size. We can do that with our variable name .set size, and we can give it the length and width, or the width and height. So let's make it 256 by 128. So the width will be 256, the height will be 128. Let's compile that and run it. There we go. There we go. Now our window is actually a little bit bigger, right? You can actually see it. There it is. My title, minimize, maximize, and close buttons. Okay. Let's set the window's position on the screen. Do a frame.set set location. And then we set the location on the screen that we want the window to be. Let's say
Save the like last one. I haven't did the 30 cents. I want to take a day just to do my assignments.
Can you
So
mute
I can
your
figure it out.
microphone?
Yes. I need a day like that, my chunky.
Alex, can you mute your microphone?
I need to find it.
All right, so we have a window, and then let's set the starting location on the screen. Let's just say it's at 400, 300 as a starting location. All right, let's run that. As you see there, our window starts right here, kind of more in the middle of the screen. That's the location, and then that's how big the window is, 400 by 300. Okay. One other thing that you almost always want to do with the window, whenever we click the X button, we usually expect the program to terminate, right? We expect the program to end. It's actually not going to do that right away. If we click the X, it does make the window disappear, but our program is actually still running in the background. And the reason why that is because you can imagine, well, maybe I want to add more than one window, right? And so if I add more than one window, if I close one, I don't necessarily want the program to end, but most of the time you do. So let's change that so that when we close the window, the program terminates. We can do that like this. So you close the program when the window is closed. Make that as a comment to ourselves. And we do that with our frame dot set default close operation. So when we close the window, what do we want to happen? We'll do this exit on close. That means whenever I close my window, I want the whole program to actually end. Let's save it. Let's run it. And there we go. There's window. If we exit, it actually does end up closing or exiting the program. See, process finished, exit code 0. That means the program actually terminated. Let me show you if we don't do that. Comment it out and we run it. There's a window, close my window, but I don't get that printout that the process is terminated. The process is still running. So let's leave that in there so that whenever we close our window, it actually ends the program. Okay, let's run it. So that's all well and good now. But if we have a window, we want to put some stuff on it, right? We want to put some buttons on it. We want to put some text input. Maybe we want to put a picture on it. There's really a lot of different things that you can add to the window. Like I said, for our example, we're going to make like a really simple calculator. What we're going to do, actually, even simpler than a calculator, what we're going to do is we're going to put 2 text fields, and you'll see what that is in a minute. We're going to put 2 text fields on it, and then we're going to put a button on it. And what we want to happen is whenever I click that button, I want it to add 2 numbers that are in those text fields. It become more clear once we start doing it. Let's close it. All right, so the next thing we need to do is, so we have this frame, we have this window, but now we want to start making the content of the window, what is actually on the window. And you put the content inside of a panel. I put, say, panel for all the window components. Oh, there we go. Nice spell. And that is what we call a J panel. Let's make a new J panel. And it also has a layout. Now, what a layout is, it is a way where Java will automatically position your widgets in the window. And whenever I say widgets, I mean the specific things like buttons and text fields and pictures and HTML links and all kinds of stuff like that. Those are called widgets, just individual small UI components. So a J panel can automatically decide where they need to be put at in the window. So when we make a J panel, we got to give it as a parameter what kind of layout we want. I'm just going to do the simplest, which is called a flow layout. I'm not going to go into detail about all the different layouts. Suffice to say, there's a flow layout, there's a grid layout, there's a border layout, there's a bunch of different layouts, and in your reading material, it talks about the different kind of layouts. We're just going to use the flow layout to keep it simple because, for our programming, the layout isn't that important. Knowing how to do the code part of it is what's important. So we'll keep it simple with just a flow layout. And now we want to tell the window that this panel is where we're putting all of our stuff. And we do that with our window, which is frame, set content pane, and we'll give that panel. So what we've done so far, we created a window that's this size at this location. Whenever we click the X button, we want the whole program to close. Now, this panel is where we're going to put all of our widgets, and we're telling the window this panel has all of our widgets. So show that. Okay. So for our first widget, let's just make a button. Let's just make a button. A button is called a J button. Make a new J button. And as a parameter, we tell it what text we want displayed on the button. We'll just say it says click me. But now we need to add the button to our panel. Like I said, this panel contains all of our widgets. Well, this button is one of our widgets. So let's add the button to the panel. Like so. Let's run that. And there we go. There's our window, and there's our button that says click me. Easy peasy. But if we click it right now, nothing is happening. And why is nothing happening when we're clicking the button? Well, the reason is we haven't made any code that says what happens when I click the button. So right now I can click it and nothing happens because we don't have any code to describe what happens. Well, let's fix that now. So the way we tell a button what to do when it's clicked, you button dot add action listener. That means when something happens with the button, this is the code that I want to run. And you have to give it a new action listener. And that's what it'll look like. We have button, add action listener. This is the action listener. And now inside of here, we have this method, and the code inside of this method is what is going to happen whenever we click that button. Right now, let's just print out something. Print ln, button was clicked. All right. So whenever this button is clicked, this code is going to be what's executed. And right now, it's just going to print something out. Let's run it. If you watch, the printout is actually going to happen down here. So when I click it, there we go. The button was clicked. Click, button was clicked. Click, the button was clicked. Okay. So now we've seen, there we go. Close it. Now, whenever I click this button, this is the code right here that gets ran. So that's going to be useful as we build out this little calculator so that whenever I click the button, it's going to add the two numbers together. That's when the program knows to add the two numbers together. All right. So I did say we're going to put two text fields on the screen so that we can put numbers in them and add them. So let's make the text fields. We'll make the first number. All right. Make what we call a J text field. That is just like a place on the window where you can click in it and then you can start typing some text. We'll call it number one, first number. It'll be a new J text field. And then as a parameter, we have to tell it how wide we want it to be. Because initially the text field is blank. So Java doesn't really know how big to make it if it's blank to start with. let's just start out with 8. It stands for columns. You'll see in a second, we'll change that number and you can see how big or how small it ends up making it. All right, so there's our first number. So let's add it to our panel. First number, and then let's see it. Let's run it. There we go. Right there, we have that text field, and we can type whatever we want in it. We can put numbers in it. We can put text in it, whatever you want to do. But that text field is this J text field first number. And by default, it's that wide, which is 8 columns. As you can see, if we can make this much bigger. Oops, let's make it 16. And you see it's a lot bigger. You end up having to put the button on the next line because it couldn't fit it beside there. That's that flow layout taking effect where Java is deciding where to put the stuff on the screen. If we move this out bigger, it moves the button beside it because it has room now. If we make it smaller, it doesn't have room to put it beside there. So the button goes down below. That's not that important for you to worry about, but just know that we made this text field and now we have a field we can type in. If I click the button, it still does the button was clicked because that's still the code that we're performing there. All right, so that's one number. Let's make a second number. As I said, our calculator is just going to add 2 numbers together. Let's change this to second number. Let's change that back down a little bit smaller. There we go. So there we go. Now we have another text field called second number. Let's run it. There you go. We have the text field first number and the text field second number. And you can type independently in either one of them. Just fine. So coming up on the last part of our UI, our little calculator here. So now whenever we click the button, I don't want it to just say the button was clicked anymore. I actually want it to add those numbers together. So the first thing we have to do is get the value of the numbers. What did the person type in? We do that like this. String first number text. Oops, let me spell it right. So this is going to be what they typed into the first box. And it'll be the first number dot get text. That's what it's going to look like. I'll explain why in a second. Second number text equals the second number dot get text. So if you remember, the first number is this JText field. The get text, it will return to you whatever the user typed in to that box. So if I typed in ABC into the box, it'll give me the string ABC. If I typed in 1, 2, 3, then it'll give me the string 1, 2, 3. The key thing to remember is that this is always a string. Even if I type in a number, it is still a string, but I need to convert that string to an actual number, because if I can't add 2 strings together, or if I add a string together, it just concatenates them, right? But I want to take the value of it and add them together. So let's make this comment. This is getting the string input. Now we need to convert string input into numbers. And how do we do that? Well, before we do that, let's print out first number text and second number text, just so you can see we are getting the right thing. So we'll print out first number text. Oops. And we'll print out second number text. Take it one step at a time, file it, run it. There we go. Let's type in A, B, C here. Let's type in 1, 2, 3 here. If I click the button, it's printing out those two strings, A, B, C, and 1, 2, 3. And that's fine. That's what we expected to happen because we just printed them out. But now, if we want to add them together, like we said before, we can't do this. Well, we can, but it's not going to give us what we think it's going to give us. Right? If we just do that, you know, what am I going to get for the result? So if I run this, even if I type in 1, 2, 3, and 4, 5, 6, what's going to happen right here when I add those two together? Well, since they're strings, it just concatenates them. And what that means is it just puts the strings, it makes one long string out of both parts, right? So this isn't actually adding the value together. So we're going to click me, you know, that's first number text, that's second number text, and then that's the result, right? It's just the numbers concatenated together. So we don't want to add the strings together. We want to add the number values together. So let's get the number values. Let's just say num1, and we do it like this. We do integer dot parse int, and then the string that has our number in it. Same thing for the second number. And let's print those out now. Num1, num2. So we still have this string that the user typed in, but now we're going to parse that string into an actual integer number. And we'll do that for number 1, we'll do it for number 2, and then we'll print them out. Let's run it. So if we put 1, 2, 3, or 2, 3, 4, click, it's actually the integer values now. So let's add those up. Sum. The sum will be num1 plus num2. And then let's just print the sum. All right. Let's run it. There we go. Type in 111, type in 222. We click it. The answer is 333. And that is those two numbers added together. All right. Last part I want to show you. Yep. So instead of printing it out, since we have some UI stuff here, let's put the answer in our window, right? So let's make another text field. So we have the first number, the second number, we have the button. Then let's add the answer, or what's called the sum, right? So it's JText field, the sum number, be a new JText field. Let's add it to our panel. So now we have another text field on there. Number 1, let's make that bigger. So first number, second number, and the sum, and then the click me. Right now it's still printing it out. But let's say instead of printing it out, let's put it in this sum text field. So to get the first number, it was first number dot get text, but now we can do the sum number dot set text and the sum. Let's run it. We're going to finish up this UI because I do want to spend a lot more time on your assignment. All right, so that we put 2, put 3, we add them together, and the answer was 5. There we go. So now we have a very, very basic functioning calculator, right? Whatever numbers you want in here, 45, whatever that number is, you add them together, and there's the answer, right? The one thing you may be thinking is, what if I don't type in a number? Type in this, because our program is trying to change this string into a number. And for 12, it can successfully do that. But how do you turn ASDF into a number? The answer is you can't. So whenever we click it, you see we actually get an error down here in our code. For your assignments, I'm not that worried about that. I'm not worried about you checking for those errors. In real world production code, you absolutely have to. But for your assignments, you can assume that the user is going to type in what they should be typing in. But I just wanted to show you that if you're wondering, what if I don't type in a number, what happens? Well, the answer is it actually crashes your program. All right, so that's all I want to go over for GUIs right now. This is the basics that'll get you started. I'm going to go from top to bottom one time, and then we'll wrap that part up. So this creates our new window with this size and that location. This says whenever I click the X on my window, I want the whole program to close. This is making a panel, and it makes it the object that contains all of my widgets. This is making a widget, a text field widget. That's how big it is. And then I add it to my panel. This is making another text field widget and adding it to my panel. This is making a third text field widget and adding it to my panel. This makes a button. This is what it says on the button. This is what happens whenever I click the button. We do button, add action listener, new action listener, and all this boilerplate code. But inside of here, inside of this action perform, that is all the code that actually runs whenever you click the button. For our example, we just got whatever the user typed in, we converted it to numbers, we added the numbers together, and then we displayed the result in the final text field. And then finally, at the end, this is how we show our window with the variable name we're using frame, dot set visible, and making it true. That shows the window. Okay. That is it for GUI right now. Now we'll get to probably what most people are interested in hearing about is inheritance and your assignment. So inheritance and your assignment really go hand in hand. Your assignment has to use a lot of inheritance. So instead of just doing straight lecture, what I'm going to do is I'm going to do an example. The example is going to be somewhat like your assignment. It's not going to be exactly. I'm not going to give you complete solutions to homework assignments, but I'm going to do an example that is kind of like your assignment, and it shouldn't be that difficult to take what I'm going to show you today and kind of convert it over into what your assignment is, right? So before we get started, let's talk about the assignment. So the assignment is you need to create a class called snack, right? And it has a specific size to it, right? Then you need to create two subclasses. I think it's fruit snack and nut snack, I think. No, fruit snack and salty snack. Yeah, fruit snack and salty snack. Now, what do we mean when we say a subclass, or it means it extends a superclass? Well, let's show you. So for your assignment, you have snacks and fruit snacks and salty snacks and large, medium, small size. Does it have nuts? Does it have citrus? Right. Let's do an example with cars. Okay. So let's make a class called car. Like I said, this will be an example that is not unlike your assignment. So I have a class called car. So let's make some variables about a car. And as we talked about before, a variable is just a way to describe a car, So how can we describe a car? Well, we can have a color, private string. The car can have a color. It can have a make, and it can have a model, right? Those are three very basic descriptions of a car, right? The color, the make, and the model. And let's do one more. Let's do mileage. We'll make it an integer, mileage. Right? So there's four things that describe a car. The important thing to note here is it doesn't matter what kind of car you have, all cars will have this in common, right? And when I say car, I also mean trucks, semis, tractors. You know, maybe it would be better to call this automobile. I don't know, but we're just going to call it car. But no matter what kind of car you have, they will all have this in common, right? So let's make a constructor for our car, public car, give it the color, the make, the model, and the mileage. And let's save that to our variables. All right. Let's make a two-string method so that we can print out our car. I know I'm typing this fast, but you can go back in and watch it at your leisure. So let's make a two-string that just kind of prints out everything about the car so that we can print it out and see which car we're dealing with. So we'll just print out the color, space, a tab, and put out the make, and then the model, and oops, and then the mileage, right? And then we will just return that string. Okay. So this is a car. It has, you know, these attributes, these variables. We have a constructor, and we set all the variables, and then we have a two-string that just prints it out. So let's make a car. Here in main, we can make a car. Let's call it car 1. Car, and what do we want? It wants the color. Let's just say it's red. Make is a Toyota model, Corolla, and it has 1, 2, 3, 4 miles on it. All right. Let's print out that car 1. Everybody should be with me so far. We haven't done anything inheritance related yet. We're just setting up our car. So if we run this, there we go. We get our car printed out right there, right? Red Toyota Corolla, that many miles. Let's make a second car. Car 2. It'll be a silver Jeep Wrangler with 2, 3, 4, 5 miles on it, right? We save it, run it. We should get both of those printed out, and we do. There's the red Toyota Corolla, and there's the silver Jeep Wrangler, right? So we have those two cars, right? Okay. Now let's talk about inheritance. So, like I said at the beginning, this car is kind of like a generic car, right? All cars kind of have these properties, right? But now let's get more specific about the car. So for example, we have gas-powered cars and we have electric cars, right? I know we got hybrid cars. We're going to ignore that for now. But we have electric cars and we have gas-powered cars, right? So let's imagine we wanted to know, well, let me show you the wrong way to do it first. So in our car, like I said, we have gas-powered cars and we could have electric cars, right? So wouldn't we want to know how much gas is in the tank? right? Maybe we need a variable to let us know how much gas is in the tank. But if it's an electric car, we might want to know what's the charge remaining, right? There, charge remaining, right? So maybe we add that in there as part of the car, the how much gas is in the tank and how much charge is remaining. The problem with that is, if it's an electric car, why would it have anything about gas? Right? An electric car doesn't have gas, right? So why would we have a variable for gas? Likewise, if this ends up being a gas car, why do we have this charge remaining variable? There is no charge remaining. There's not even a concept of charge remaining, right? Because it's a gas car. So that concept of a gas car and an electric car, you can think of them as they're still cars, but they're a more specialized car, right? So let's take the gas and charge out, and let's make a new class called electric car. And we will say it extends car. Now, what does it mean to extend car? That means electric car, it is a car. It is the same thing as a car, except it is a more specialized car. So this electric car, since it extends car, so your electric car, it still has all of these variables. It still has all of these methods. I don't have to explicitly type them back out, but they exist for this electric car because it extends car. So let's make some more variables. And why do we need more variables? Like I'll show you in the example of a wrong way to do things. You know, we were going to put the charge remaining here in the car, but it didn't make sense. Let's add it to our electric car. Now that makes sense. So now electric car, it has a charge remaining, but since it extends car, it also has a color, a make, a model, and mileage. Likewise, if we can make a new class, we can make a gas car. We can make it extend car. Oops. And instead of charge remaining, it'll be gas in tank, right? Let's say gallons, gas in tank. That's good enough. Right? So now, since we have separated out gas car and electric car, now electric car has a charge remaining, but it doesn't have the gas in the tank. And that's fine because that's how an electric car is. Likewise, for gas car, it has the amount of gallons left, but it does not have the charge remaining. And that's fine because the gas car doesn't have that. But since they both extend car, both of them extend car, that means they have their own new stuff plus whatever car has. So since car has color, make, model, and mileage, that means the electric car has color, make, model, and mileage. That means a gas car has color, make, model, and mileage. So let's go back to our main. So instead of making a car, let's make an electric car. Instead of this car, let's make it a gas car. And let's run it. And right now, we're not going to see a difference yet. And we see the same thing here. But now with the electric car, you know, we have all those same variables, but we also have the charge remaining that we need to set. Let's call it charge. Let's look at the constructor for a second. So for an electric car, we have all of those same parameters for a car, the color, make, model, and mileage. And we also have to give it, you know, what the charge remaining is. So what's this right here, this super, and then those parameters? What this is doing, since we extend car, this super is calling the car constructor. This is our electric car constructor, and it is calling our super constructor. Our super is the class that we are extending. So this is calling the constructor of car. And we're going to give it the color, make, the model, and mileage. If we look at the constructor for car, there it is, the color, make, model, and mileage. So that's what that super is doing. It's calling the car's constructor. And then of course here, we're also setting this charge remaining. We need to do the same thing for the gas car. Same thing, we have the color, make, model, and mileage. We also have, which one call it gallons. All right. Same thing as the electric car, except now we're dealing with these gallons. We still call these super constructor, and then we also save how many gallons it has. Let's go back to main. So with the electric car, we have the color, make, model, mileage. We also have the charge. Let's say it's at 55% charged. Do 0.55 to say 55%. And for the gas car, let's say we have 5 gallons of gas left in it. Let's run it. It compiles and everything runs. We still don't see any change in the output yet. Let's do that. So whenever we print out an electric car, you know, we want all of these details. We also want to know what the charge in it is, right? So with an electric car, let's make a toString method. So let's get all the same information, the color, make, model, mileage. You can see something I'm doing wrong here. It's okay. So we want this color, make, model, and mileage, right? But car is already doing that work for us. The car toString already gets us the color, make, model, and mileage, right? So what we can do, our electric car, we can do super.toString. Just like this super called the car constructor, this super.toString is calling the car's toString method. And if we look at the car toString, then it makes this string for us with the color, make, model, and mileage, and it returns that string to us. So here we're just going to say this string S is equal to that car's, whatever that car did. And then we can add on to the string the charge. So what we did, we have the electric car has its own toString. We're getting the string from the super class. The super class is car. We're going to add on to that string the charge remaining, and then we're going to return that string. Let's do the same thing for the gas car, almost the same thing. But instead of charge remaining, it's the gallons, right? So now whenever we run the program, there we go. We have an electric car, a red Toyota Corolla with that many miles, and the charge is at 55%. We have a silver, for a gas car, we have a silver Jeep Wrangler with that many miles, and there are 5 gallons in the tank. Okay. Last part of this example we're going to do, and then we'll go to questions and answers. Let's say we want to compute how much, what's the tax we owe on the car. Okay. So let's make a new method, make a public float compute tax. What it'll do, it will compute the tax and it'll return it as a float. So I know this isn't real world how they compute it. Let's just say the tax is computed by how much mileage is on the car, right? So we'll compute.
When Charles had begun rampaging through Poland, Ivan began to negotiate with him.
We're going to compute tax based on mileage, all right? We're just going to make up our own tax formula. Let's just say the tax is 10% of the mileage. I don't know. The tax is the mileage times 0.10, 0.10, right? And then we'll return that as the tax. Okay. That's probably not how they really compute tax. Let's just say in our fictional world, this is how we compute the tax. And it's just how much mileage is on the vehicle times 10%. Okay. So let's go back to our main and let's compute the tax on both of these cars. We'll print that out too. We're going to print the car1.compute tax. And car2 compute tax. We'll just print that out. So when we run that, we get the first car, and that's the tax. And is that right? It is, because that's the mileage. We said the tax is going to be 10% of the mileage, and that's 10% of the mileage. Same thing for this one. That's the mileage, and there's 10% of the mileage, which is the compute tax. Okay. Now here's where we're going to use a little bit of inheritance. So let's say the tax isn't only based on the mileage. Let's say gas cars, let's say gas cars have a higher tax. Let's say we want to put a higher tax on the gas so that we encourage people to get electric cars. Whatever the fictional reasoning is you want to make up. But the fact remains is that a gas car is just going to be more tax. Okay? And we'll actually say an electric car has less tax. So how do we compute that? Well, first of all, let's put in the same mileage for both so that we can see both taxes are equal right now. So we run it. There we go. Both of them have the same tax because they both have the same mileage. But now let's say an electric car has less and a gas car has more. Well, since we have this method called compute tax here in car, we want to do what we call override it. That means in a subclass in electric car, we also want to have that compute tax method. And it's going to override this one. That means this, actually it'll work just like the string. Be easier when you see an example. Say override the compute tax. And let's do the same thing for the gas car right now. All right. So now this is what's going to happen when you have a gas car and you call it compute tax. Same thing with our electric car. If you have an electric car and you call it compute tax, here's what's going to happen. And in both of their cases, they're just going to call the super classes compute tax. like we said, the superclass is car. So if we have an electric car and we call it compute tax, right now, the only thing it's going to do is call the superclass's compute tax and return that. And what is that? It's the car where it's only based on the mileage. Let's run it. You can see there's no change in what's printed out. See, the tax is still the same, right? But let's say with an electric car, it is that mileage tax, but it's at 75% of the mileage tax. And for gas car, let's say it's double. That's not double, that's 50% more. Let's say it's double. Let's run it. And there you go. You can now see that the electric car costs less and the gas car costs more, even though they have the same mileage. Because what happened is, let's just run through the electric car example. We had the electric car. We did the electric car compute tax. What happened with the electric car compute tax? It went to this electric car compute tax. It computed the superclass's compute tax. The superclass compute tax is the car, and it just figured out a percentage based on the mileage. So this was the tax only based on the mileage, and then we're going to say, well, it's only 75% of that. So you got a 25% discount because you have an electric car. Likewise, the gas car did the same thing, but when it computed the tax based on the mileage, it then doubled it to compute the tax for a gas car. Okay, so how does this example tie back in with your assignment? Well, for your assignment, you have a snack class, and the snack class is like our car. It has things that are common to all snacks. So for your assignment in here, you probably have like the size of the snack. And I think you need an ID of the snack. You also need a method to compute the price of the snack, right? Then you also have two child classes, one called fruit snack and one called salty snack. It's like our two subclasses, electric car and gas car. And it says your fruit snack, it has an indicator if it contains citrus, right? Here we had a variable for charge remaining. You would probably have a variable for, does the fruit snack have citrus or not? In your salty snack, instead of gallons, you probably have something in here that doesn't have nuts in it or not. And then when you have to compute your price, kind of like we're computing the tax here, the snack by itself will compute the price based on the size of the snack. But if your subclass, like if it has nuts, there's an extra charge. Or if it has citrus in it, there's an extra charge. So just like we computed a different price for tax, depending on the electric car, this car, we computed a different price for the tax. That's the same way that you need to compute a different price depending on if it's a fruit snack with citrus or a salty snack with nuts. And then the other part you have to do for your assignment, you actually have to do an order system. I'm not going to do that for our example, but you just need to do some printouts so that you let the user type in what they want. The user should decide, if they want a salty snack or if they want a fruity snack, and a large, medium, or small, and then also with citrus fruits or with nuts. I'll leave that part to you to figure out how to get input from the user. It's been covered in the reading assignments. And then, if the user types in on the keyboard, salty snack or salty, or however you want to handle it, then you should make a new salty snack, and with or without nuts, and then you got to compute the price for it. Okay. That it takes me to the end of the material that I'm going to cover today. I said at the beginning we went over some UI material. That's the reading material in the assignment currently. But also we went through and did this example for this car base class. And then we got 2 child classes, electric car, which extended the car, and gas car, which extended the car. The thing you have to remember, and it trips up most people whenever they first start with inheritance, is a gas car. It is a car. It's just a more specialized car. And also, since gas car extends car, that means it has everything that car has. So when gas car extends car, that means it has all of these variables. It has all of these methods. But since it's more specialized, we're adding more stuff to it. And we did so with that the gallons here, and then the charge in the electric car. Okay, that wraps it up. Reminder, your assignment is due by 11:59 p.m. Eastern Standard Time on Tuesday night. I will get this video posted here in the next hour or so that you can go back and rewatch it, review it at your leisure. If you need any help, you have to email me and you have to let me know what you need help with. If you don't speak up, I won't know you're struggling. And if you send me an email asking for assistance, then I ask that you please be specific with what you need help with, and also attach your Java files to the email as well, so I can look at your code and try to help you figure out what you're doing wrong. But if you send me an email that just says my program is broken, that's not very helpful, and I don't know how much I can help you. If you send me an email and say, my program is having this X, Y, and Z problem, and here's my code, here's what I tried, that's much more helpful, and I can steer you in the right direction. So when you ask for assistance, please kind of be specific about what part you're having trouble with. All right, we'll go ahead and open it up for the next few minutes for any questions and answers. So the floor is open. All right, nothing heard, no questions in the chat box. Go ahead and wrap it up, and I'll get this video posted shortly. All right, everyone, have a good night.